We can continue with session 2, landfilling. Professor Dr. Barışçalı will be on chair. Barışçalı, you can start.
Okay. Thank you for introducing me. Are all the presenters here? Could you please
Raffaella
say
Cossu
hello?
is absent, I think.
Who is absent?
Raffaella Cossu is absent.
Okay, the keynote speaker is absent. Okay.
Mm-hmm.
Dr. Virendra Kumar, is he here?
He is absent too. He was in here, but he's not here right now.
Okay, right now he's not here. Okay, because I saw him in the morning session. So, and the third speaker, Benen Yazıcı Karabulut, is she here?
Yes.
Yes, I'm here.
Okay, just a moment. I will check one by one. So it's and then the speaker from Brazil, Priscila Maradini, is he here?
He's not here. He's absent.
Okay, she's also absent. And the last speaker from Pakistan, Fiza Faiza, are you here? No.
He's not here too.
Okay. Okay. Then we have only one presenter.
Really?
Yes. Anyway, welcome everyone. So
they will come lately, maybe. If they come, I can tell you this.
Sure. Okay. So let me start this session. Good afternoon, everyone. Welcome to session 2, landfilling. I'm Professor Barışçalı from Marmara University, which is one of the largest universities in Turkey, in Istanbul. Let me introduce you the only speaker that we that present now, and she's Benan Yazıcı Karabulut. She's a research assistant at Harran University, Environmental Engineering Department in Şanlıurfa, Turkey. In the meantime, she's doing her PhD study on groundwater treatment in the same department. But today she will talk on a different subject, and the title of her presentation is A Study on Evaluation of Site Selection in Sanitary Landfill with regard to urban growth.
Yeah.
Okay, Ms. Karabulut, the floor is yours. Please, okay. We don't have the other presenters, but it's better to keep to be on time. Please keep your presentation as 15 minutes, okay, please.
Okay, thank you so much, Professor Çalı. Hi, everybody. Today, I try to explain our study. Our topic is a study on evaluation of site selection in central landfill with regard to urban growth. So firstly, I will give you some basic information about the site selection in central landfill. The Sanitary, the Sanitary landfill is widely used waste disposal method worldwide due to its safe and economic. The most important issue in the storage method is the process of selecting the landfill. And this process is one of the critical issues in the urban planning process due to its enormous impact on the region's economy, ecology, and environmental health. Urban growth is a phenomenon that is difficult to stop or limit in line with economic dynamics and demographic changes. For this reason, site selection in solid waste center landfill is a great importance in terms of ensuring sustainable urban feature, and the site selection in center landfill is made conventionally considering environmental, social, and economical criteria. So, What is the aim of our study? The waste disposal facility, which was built according to the mentioned criteria and still in operation, was evaluated in the context of urban growth. In this context, Landsat TM 1989 satellite image for the determination of the central sentiments area of Şanlıurfa before the irrigation of the GAP project, and Sentinel-2 satellite image enrichment to determine the urban development boundaries after irrigation was mapped by screen digitizing. And then its spatial evaluation and mapping were performed by means of ArcGIS software. So our study area is Şanlıurfa, and this city is located on the southern skirts of the central part of the Southeast Taurus Mountains. Mountains and high hills in the north of province descend towards the south. The Great Plains are in the southern half, raw hills are quite common. Suruç, Harran, Viranşehir plains, which are lined from west to east, are among these mountains, and the area of Şanlıurfa land is 18.584 square kilometer. So our methodology is during the analysis of the urban change of the city of Şanlıurfa, Landsat 5TM and Sentinel-2 satellite data were used in 1989 and I'm so sorry, 2019 respectively. Landsat TM 1989 satellite image and Sentinel-2 satellite to determine the boundaries of urban development after irrigation were mapped by image enhancement screen digitizing. Spatial evaluation and mapping were done in ArcGIS software. The used Landsat 5TM satellite data belongs to 1989. The Landsat 5TM sensor, which has been used since 1984, has 6 bands with 30 meter resolution and thermal band with 120 meter resolution in the near and middle infrared region. Each Landsat TM image covers an area approximately 185 by 185 square kilometer. And then what is urban growth? Rapid urban growth is developing contributes greatly increasing problems related to unemployment, poverty, inadequate healthcare, low quality of life, damage to nature, poor water quality, and deterioration of living environments, especially in rural areas. In order to prevent these problems, central and local government actors must act together with urban growth management units, subunits, and produce results as shown in Figure 1. Mapping, modeling, and measurements of urban growth can be analyzed using GIS and remote sensing-based statistical models. Thanks to these technological developments, the change in temporal and spatial scale of complex urban systems and the direction of this change have become analyzable. So, classification of solid waste landfills. Storage areas are divided into two groups as irregular storage areas and landfills. In irregular storage areas, which is used in developing and underdeveloped countries, solid waste in waste storage areas are discharged irregularly into open land without taking any precautions and removed from the human environment. And the landfill facilities can be defined as places where waste are accepted as controlled waste are disposed of above ground and underground according to some technical conditions, and the waste generated as a result of the mechanisms formed in the waste after storage are controlled. Although the landfill is at the bottom of the waste management order, is a widely used disposal method in many countries around the world. Researchers emphasize that since determining the location of the storage facility is a difficult and critical stage, solid waste management is not only an environmental issue and should not be ignored in various socio-cultural and economic issues. As shown in figure 2, site selection criteria for center landfills: economic, environmental, climatic, geological, and social criteria. So, identification of the criteria is site selection is a complex spatial decision problem that offers many alternatives for decision makers and carries different preferences. That is, this choice is not easy and unilaterally definable. It's a difficult and long-lasting process to evaluate the existing information regarding the selection of the study area with classical methods. A model is needed that considers the importance of all three: environmental, economic, and socio-cultural criteria at the same time. Figure 3, use of GIS, MCDV, remote sensing technologies for choosing the appropriate place for waste storage. So, our resultant discussions, in our study, classification results for 1989 and 2019 are shown in figure 4. Yes, this is the figure 4. So, classification results of satellite image differ visually. In this image, mainly green areas are gathered, especially in the south of the city. It's understood that the I'm so sorry, I tried to. It's understood that the construction works in the northeast and southeast axis of the city have increased over a 30-year period. Especially in this process, it's seen that industry and construction areas interact. It's observed that the settlements also differed in these 30 years. In general, the population increases twice every 32 years, and the direction of the development area was determined by considering the land resources of the plain, the development direction of the city, and the area suitable for the urban structure. Yeah, classification results for a 1989 and 2019. So, since its development towards the lands of the Haram Plain is prevented by the law no. 5403 on soil protection and land use, the development is mostly towards Karaköprü, organized industry, and Fatih Mountains. For the settlement of center landfills, many effective criteria such as distance from residential areas, distance from main roads, investment cost, presence of solid waste, geology, surface water, aquifer, land use, elevation, and land slope should be considered. There are various techniques for landfill selection, including a geographic information system, mathematical models, heuristic algorithms, and different multi-criteria decision-making method using analytical hierarchy process and technique. Then, consequently, when the distance of the center landfill site to the city periphery at the site selection investigation stage is 4 kilometers in 1989, as of 2019, as a result of the increasing population and the related urbanization, the city and the landfill area are almost intertwined, and the distance has decreased to 800 meters. In the past 20 years, the failure to stop, limit, or control this growth should lead to the self-criticisms of central and local government actors' powers and responsibilities. Likewise, this situation has started to pose a serious problem in terms of environment and public health and has been recently caused the need to a new site selection for Sanitary landfill in Şanlıurfa. This fact is not specific to the province of Şanlıurfa. Unforeseen environmental threats have started to emerge as a result of socio-economic pressures such as industrialization, urbanization, migration, and population growth, especially in metropolitan settlements. Our presentation finish here, and these pictures from our university, Hara University, and thank you for your participation. Do you have any questions?
Yes, are there any questions, any contribution to actually thank you for this nice presentation, Ms. Karabulut. Any question? Let me ask you one simple question, a short question. Are there any other locations suitable for landfilling in Şanlıurfa, or the suitable places are limited? Do you have any information about it?
Not yet, but we are works on it, and we try to choose a new landfill site for the new one. Yeah.
Okay. Yes, Şanlıurfa is a very big, huge, one of the huge provinces in Turkey, and it's very highly populated. So it's very important to have proper municipal solid waste management facilities. Thank you. There is no other question. That's why I thank you for this nice presentation.
Thank you so much for your time.
Thank you.
Okay.
And
Mr. Maradini is here. If you want it, we can continue with him.
who? I couldn't hear.
Mr. Maradini.
Maradini. Okay. Priscilla. And also, I think I saw Dr. Virendra. And Dr. Virendra, are you here in this session? I saw you that you participated, but still silent. Okay, no problem. So now we will continue with Miss Priscilla Maradini. She's a master's student in environmental quality, waste treatment and resource recovery at the Federal University of, sorry my presentation, but Viçosa Agricultural Department in Minas Gerais, Brazil. Maradini received her BSc in environmental engineering in 2018 from the same university, and she's now participating from a very long distance from Brazil. What is time now there?
It's 9:20 in the morning.
9:20 in the morning. Okay, that's anyway. It's good morning to you then. And
good morning, afternoon, and good night.
Okay. Anyway, so with the technology now we can communicate with each other very efficiently, and she will present a very interesting study and estimate of biogas and electricity generation in landfills, a study for the state of Minas Gerais in Brazil. Please, the platform is yours. We are listening to this interesting presentation.
Okay, hello everyone. Thank you all for being here. Can you see my presentation?
Yes, could you please do it full screen or, yeah, okay, slideshow, okay, thank you.
Okay, so I'm going to present this research that I'm part of, entitled Estimate of Biogas and Electricity Generation in Landfills, a study for the state of Minas Gerais, Brazil. So in 2017, in the state of Minas Gerais in Brazil, 60.1% of the urban population send their municipal solid waste to appropriate locations with environmental regularization process completed. 10.5% of the urban population send their municipal solid waste to appropriate locations with environmental regularization process underway. And 29.4% of the urban population send their municipal solid waste to irregular units as open dumps and controlled tipping. So in 2003, the State Foundation for the Environment created the program Minas Sem Lixões, that would be Minas without open dumps, in order to support the municipalities to attain the standards of a proper municipal solid waste management. Would be sending their waste to landfills. Once the landfills has a greater environment control, as for example, the collect and use of biogas, that can reduce the greenhouse emissions, generating electrical or thermal energy from biogas recovery, generating income, and also improving the energy sustainability. So in 2017, the biogas production in Brazil, the main categories of this biogas production in Brazil was the wastewater treatment, 5%, the agriculture, 29%, the co-digestion, 1%, the industry, 22%, and the landfills with 43%. But only 7% of the units that that is on the landfills really recover the biogas for energy production. So we have a study from Santos et al. In 2017 that showed that 41% of the landfill's potential energy in Brazil would be concentrated in the southeast region. That's because this region is the most populous region in Brazil. So is the one that contributes to the highest municipal solid waste generation. Another study made by Nascimento et al. 2019 showed that the biogas collection from landfills from 2003 to 2016, only 8 projects of biogas is burning in flares in Brazil. And the same study showed regarding the biogas recovery from landfills from 2004 to 2015 showed that Brazil only have 9 thermoelectric plants, which is a very low value for the regarding the Brazil potential. In this way, given this scenario, this work aimed to estimate the production of methane and the potential energy from the anaerobic degradation of municipal solid waste, considering the implementation of landfills in the municipalities of the state of Minas Gerais that do not have a proper disposal for their waste. So our study was developed in Minas Gerais in Brazil, that in 2019 had a population of 21 million inhabitants. And this state is divided in 12 mesoregions that we can see here. So we have all the mesoregions, the name of them, and the total municipalities that's it's from each of them. And there's these other 3 columns is we took the numbers from the report Classificação e Panorama de Destinação dos Resíduos Sólidos Urbanos em Minas Gerais from the year of 2019. So we could classify the destination of the solid waste in Minas Gerais. So here we have a total of 419 municipalities that send their municipal solid waste to irregular destinations, divided in 196 going to a controlled tipping and 223 that send to open dumps. We also make and georeferencing of all the data. We could create this map that shows the state of Minas Gerais in Brazil. And then all the studies that, all the municipalities that's under our study, that's the one that are colored. So if the destination of their waste is from open dump, they are colored by orange. And if it's for controlled tipping, colored by blue. And then, I don't know if you guys can see, but we try to put the limitation of the mesoregions with this black mark, a little bit strong than the others. And also all the municipalities that's not colored is not our understudy. We divided out methodology in 6 steps. So the first one, we calculate the population projection using the geometric projection method, using this equation, for the years of our study, that's from 2020 to 2040. We also use the data from the Atlas of Human Development in Brazil, using the years of 2000 and 2010 as the base years to calculate our projection method, and then to calculate our population projection, and then could project this for our study years. The second step is the per capita generation. We took them from the National Information System on Sanitation from 2017, getting an amount of 0.7194 kilograms of municipal solid waste per inhabitant per day. So this value, we collected all the municipal solid waste and the population attended by the household collection. The third step is the calculation of the biogas potential. So for this, we used the software LandGen from the USEPA, that's the United States Environmental Protection Agency. We use this equation. And for the parameters necessary to the equation, we took them from the literature. And I would like to highlight this one, the methane generation rate, because the value was different for the Norte de Minas mesoregion, because this methane generation rate is based on the average annual rainfall. So that's why it was different for this mesoregion and the same for the others. The electricity generation, we consider the internal combustion engines to make the conversion from the biogas into electricity. So we use this equation, and the parameter that's necessary to equation, we took them from the literature. And after we calculate the equivalent population index, that would be the number of inhabitants per mesoregion that could have their energy needs supplied from the biogas recovery. So for that, we use this equation, and this parameter took also from the literature. And finally, we made a projection of final methane and energy production. For that, we grouped all the mesoregions results and made a time series considering the landfills operation starting and ending years from 2020 to 2040, and plus the subsequent years until the final methane and energy generation. So here we have a map showing our results. So we have the potential for methane and electricity production for the years of 2030 and 2040. So we made the study for all the years from 2020 to 2040, but it would be difficult to put like 20 graphics. So we choose the years of 2030 and 2040 to show the results. And you guys can be thinking, what about the year of 2020? So as this year is considering the starting year, so there is no methane production and consequently no electricity production. So that's why we don't have a map for that. And here in this map, we have all the mesoregions and their number. And we have colors, different colors and different sizes of these balls. So the balls represent the methane production, and the color, the electricity production. So increasing the intensity of the color and the size of the balls, we have the increase of electricity and methane production respectively. So we have the mesoregion Metropolitana de Belo Horizonte, that's the number 7, this one, as the one that had the higher electricity production and methane production for both years, with this amount of 20.48 million cubic meters and 69.63 million kilowatt hour in 2030, and 35.49 million cubic meters and 120.67 million kilowatt hour in 2040. And we have the mesoregion Campo das Vertentes, that's the number 11, this one here, as the one that has the less methane production and electricity production, which the number of 3.55 million cubic meters and 12.09 million kilowatt hour in 2030, and 5.88 million cubic meters and 1999 million kilowatt hour in 2040. This table shows the equivalent population index for all the mesoregions in 2030 and 2040, and we can see that the mesoregion Vale do Mucuri was the one that got the higher equivalent population index. However, this mesoregion was the 4th lowest potential to methane and electricity generation. And the Metropolitana de Belo Horizonte mesoregion was the one that got the less equivalent population index for both years. However, it was the first potential generation of methane and electricity. Here we have the time series of methane and energy production over the year. And we can see that we got the maximum value in 2041, which is the first year before the end year of the use of the landfill. And we have the 2120 as the final year of methane and electricity production. So we can say that the methane and electricity production remain even after the final landfill's activities. So here in this graph, we got 8 years after the end of the use of the landfill, and we still got some of methane and electricity production. We decreased this amount, but still had. So it's one of important result that can make the government think about that and change their destination of waste. So the conclusions, we can say that the treatment and proper disposal of municipal solid waste are an urgent need in the municipalities of Minas Gerais, Brazil. The biogas can be recovered and used to produce energy. The quantified percentage is small in terms of energy supply to big urban centers, but the electricity generated could be used to supply small rural communities and population nucleus nearest the landfills areas. The results of this study can be used as a management tool to guide public investment policies in renewable energy sources, especially in locations that still dispose their waste inappropriately. And the use of biogas from landfills represents a positive externality of the proper disposal of municipal solid waste and can contribute to the increase of the Brazilian renewable energy metrics. I'd like to thank for the founding agencies in Brazil, which is the CNPq, CAPES, and FAPEMIG, and also thanks to the Agricultural Department of the Federal University of Viçosa in Brazil. And I would like to thank you all of you that's watching, and I'm here if you guys have any questions. Thank you.
Thank you, Ms. Maradini. A very nice and very interesting presentation and study research. And any question, any contribution from the audiences? If there is no, I would like to ask one.
Okay.
And because I'm also familiar with these types of studies, but it's maybe I missed while you were presenting. What about the variables, the parameters that you use? I understood that you got them from literature or from
Yes.
you use some EPA or some international models, and the parameters, the variables, you got them from the literature. But it's in some cases in Turkey, if we use the parameters or the variables from countries like United States or Europe or something like that, sometimes the models may not fit. The most important thing is the biodegradability and the organic content of the municipal solid waste. Do you have any knowledge about it, the moisture content and the organic content of the municipal solid waste? That's my question.
Yes, so we started using another method that used this kind of parameters that we had to divide between the constitution of the waste, like in terms of paper and like all the divisions. But then we changed for another method, that's the USEPA method, that doesn't need this kind of studies, because these studies from a class that we took as our study, and then we didn't have so much time to go to a field to get all the parameters and these numbers. So that's why we use more the literature. But I think it's very important to use the real data, because as you said, each region has specific data. So it's really important to use the one from the real, the reality, right?
Yeah. Because as I see from your results, to reach to the maximum landfill gas production, it takes some time. But if the organic matter content and the moisture content is suitable in the landfill, you can reach to the maximum production within few years. So you have to be careful. Okay. So if there is no other question, I see something in the chat, but okay, they thank you for the presentation.
Mr. Çallı, Dr. Kumar is here. We can continue with him if you want.
Okay, I see that he's on the as a co-host. Thank you very much for the presentation, Ms. Maradini, again. So now the next speaker, actually the second one in the list, according to the list, Dr. Virendra Kumar. Virendra Kumar. Is he here? Dr. Kumar? He was Virendra Kumar. I see you on the participants list. Is there any problem with the connection? I cannot hear him. Anyway.
Mr. Çallı, if Dr. Kumar is absent, we can continue with Mr. Faizi.
Okay.
Mrs. Faizi, excuse me.
I think she, as I understand from her CV, Miss Faiza, are you here?
Yes, I'm here and I can listen to you.
Okay, thank you very much. So I will simply introduce you. Please keep for a while. Now the next speaker, Miss Fiza Faiza. She works as a volunteer researcher at Remote Sensing, GIS and Climatic Research Lab Department of Space Science in University of Punjab in Pakistan. She received her BSc and MSc degrees in 2014 and 2018 from Department of Space Sciences and GIS and Remote Sensing from the University of Punjab, respectively. She's currently working on environmental application of geospatial technologies, particularly municipal solid waste monitoring and identification. And the title of the presentation she will do, Satellite Remote Sensing and Image Processing Techniques for Monitoring Municipal Solid Waste Dams. Probably, I think, the data from Pakistan. and it's we are waiting for your interesting presentation. The platform is yours, please.
Thank you. Hi everyone. Today the topic which I'm going to present here is the satellite remote sensing and image processing techniques for monitoring municipal solid waste dumps. This is the basic outline of my research work. Now, the basic research question behind this research was that how remotely sensed data can be coupled with image processing and GIS techniques so that it can be helpful for planning MSW management strategies, cost-effective and time-effective MSW management strategies. I have also elucidated in detail here my main objectives of the study: to explore freely available data sets, to make a comparison of the relative effectiveness and accuracy of the data sets in detecting and identifying municipal solid waste dumping sites in a particular area of Pakistan, and lastly, to assess the accuracy of those maps presented by the study. Formerly, some work regarding the remote identification of solid waste dumping sites had been done by aerial platforms, and also some researchers had worked on satellite images. But the limited accuracy of those researches and the absence of the application of novel statistical remote sensing and image processing techniques, it suggested that there is a critical gap in literature which should be fulfilled by using more advanced image processing techniques and integrated GIS technology so that we can devise cost-effective and time-effective management solutions and for the remote identification and segregation of MSW waste. And here in this lies the significance of the study, because it tends to replace the costly and laborious in situ measurements, the costly and laborious ground and field measurements, and we can identify waste disposal areas, which is a first step towards hazard assessment of sites, which act as significant pollution sources. And it will help concerned authorities devise low-cost energy and waste management solutions. In the province of Punjab, Pakistan, my study centered upon the district Faisalabad, which is also called the Manchester of Asia because of its textile industry, which is renowned throughout the world. In the city of Faisalabad, my study focused on two authorized legal municipal solid waste dumping sites which collect where the waste from whole of the city of Faisalabad is collected and dumped. As you can see, there are two of these. This is the old dumping facility of Faisalabad, and this is a new dumping facility of Faisalabad city. I have used in this study two remotely sensed data sets. One belongs to the Sentinel-2, a multispectral imager sensor, and the other data set is of Landsat-8, operational land imager sensor. Sentinel-2 MSI sensor, the wavelengths I chose for my study were 20 meters, having a spatial resolution of 20 meters. And Landsat-8 OLI sensor data had a spatial resolution of 30 meters. Along with the remotely sensed data, I used ancillary data, which comprised of two categories, GIS data and ground reference data. For ground reference data, I carried out two field surveys. One was the pre-classification landfill information survey, and the other was the post-classification accuracy assessment survey. Now, for both of the datasets, two types of classification techniques were employed to study and to identify the landfill sites and the openly dumped sites from remote perspective. One is the ISO data classifier, which is a renowned unsupervised classifier, and the other was maximum likelihood classifier, which was also a very robust technique for supervised classification procedures. The methodology of my study is as follows, as I elucidated hereafter. Uh, First of all, to remove redundancy from the bands and various wavelengths, optimal feature selection and optimal band selection procedure was done. And after selecting bands that were representative of all parts of electromagnetic spectrum, their layers were stacked and the image was subsequently cut to the bounds of the study area, which is known as image subsetting. Now, after the required subsetting, the process of multispectral image classification was carried out. Now, for two of the data sets and for two of the algorithms being used in this study, four classification schemes arise. One is Sentinel-2 supervised classification scheme. Number two, Sentinel-2 unsupervised classification scheme. Third, Landsat-8 supervised classification scheme. And lastly, Landsat-8 unsupervised classification scheme. The parameters of the unsupervised classification, which resulted in 70 spectral classes, are given in the table format. You can see after the classification procedures had been done, this is the graphical representation of unsupervised classification result of Sentinel-2A multispectral imaging. All of the areas which related to the openly dumped solid waste authorized landfill sites of Faisalabad cities. You can see over here the older landfill facility and the newer landfill facility. Same is the case with unsupervised classification of Landsat-8. You can see here all being detected by the satellite, the older landfill site, and this one is the newer landfill site. And similarly for the supervised classification scheme, this one is the older landfill site of Faisalabad and this one is the newer landfill site. For the Landsat-8 OLI image, the supervised classification scheme you can see here in the picture, the older municipal solid waste dumping site of Faisalabad, and this is the new one. Now, the interesting things you can see over here, what I had done after the classification scheme was that all the areas which were qualifying and which were being detected by the satellite as openly dumped solid waste, these are represented in the red category, MSWOD category, and all the remaining areas, whether it was vegetation, soil, residential area, water, these were lumped into, and the other category which you can see in the background is a yellowish green color. Now, it was interesting to note that apart from these areas which represented the true landfill sites of Faisalabad, many other areas have also been detected by the satellite as municipal solid waste open dumps. And the question arises, why is it so? Are these areas really covered with dumped solid waste of some kind, or these are mere classification errors? To judge the accuracy, in order to investigate this question, that whether these polygons which are acting as potential candidate sites for these polygons, and you can see them in all of the classification schemes, we wanted to investigate that it's okay that these two sites are being detected in every classification. What is the true identity of these other polygons? Are these true land cover sites? Are these true MSWOD sites, or whether these are mere classification errors? So, in order to evaluate the accuracy of the classifications, in order to investigate the true land cover type of these polygons, we carried out a post-classification accuracy assessment procedure, which involved a field survey. Firstly, now what did we do that after the classification was carried out, the results were in the raster format, so we firstly converted into the vector format and removed all those areas which were classified as non-MSWOD areas, and only the potential candidates for municipal solid waste open dumps have been left behind after this scrutinizing process. This is a flowchart of the methodology. You can see over here, pre-processing of the imagery, and after that, rectified stacked image. Classification schemes have been carried out and or for each classification scheme, vectorization and area filtering process was carried out. Now, MSW candidate sites have been left behind. We have to carry an accuracy assessment procedure for them with the help of ground reference data so as to evaluate the accuracy of our procedure. Here comes the resultant discussion. So what happened that when we went to the field sites, and for each and every polygon which had passed all the stages of post-classification, recoding, and vectorization, and area filtering. Now, all the polygons which have been left behind in the MSW category, we want to ascertain the fact what are they truly in the real world, and for that we carried out a survey and found it. And there are some certain astonishing results that some barren agricultural fields or some types of abandoned land areas with soil or sparse vegetation, some rural swamps which had stagnant wastewater, rural residential areas, and certain roadside stretches of land were actually being detected by the satellite imagery as true openly dumped solid waste areas. For both of the satellite datasets, for Sentinel-2A as well as for Landsat 8.
Miss Faiza, could you please sum up, please, so it's come to the conclusion? So
Yes, we carried out this survey and found that although these areas were not legalized or authorized places for solid waste dumping sites, what happened was their rural communities were throwing some organic waste, some demolition waste, and some type of biological waste. So in these areas, these were adjacent to rural communities. So the satellite was only detecting the reflectors from these areas, which was true representative of the openly dumped solid waste. Same was the case of the marshes, on which you can see near the rural areas algal bloom and many types of suspended solid waste particles are over here in these marshes, and the satellite detects them as solid waste dump areas. This is the same as the case with this roadside stretch of land. So after carrying out this accuracy assessment survey, we calculated the accuracy of our classification schemes. These figures represent for each of the satellite data set, the accuracy for each satellite data set. Spectral reflecting curves were subsequently generated. Vegetation, soil, dry land, residential water, and open dumps are clearly being segregated from each other by the satellite data sets. And the last interesting thing to note after this study was carried out, that the freshest waste was reflecting the least, while the oldest waste was reflecting the most. This is the case for Landsat 2A data. Same is the case for Landsat 8 OLI data. The waste which was less than 5 years old was reflecting the least, whereas the waste which was most old and greater than 10 years old, it was reflecting the highest. The reason behind this behavior was that the freshest waste contained a huge quantity of water, and it was coarser. It contained coarser fragments. It was coarse in texture, and water absorbs a lot in the visible and infrared wavelengths and all along the electromagnetic spectrum. So this was the reason behind its low reflectance. Whereas the oldest waste, which has undergone a lot of disintegration and which has undergone a lot of chemical decay, its texture is transformed from coarse textured particles to fine textured particles, and the water in it, the content in it has largely been depleted. So it reflects the highest. And this is a very interesting thing to note, that satellite can even has the capability to segregate between wastes of different, even having the same chemical composition or near same chemical composition. If its age is different, then satellite can detect it very effectively. According to the accuracy statistics, you can note here that Sentinel-2A imagery is having higher accuracy measures in both for isodata classifier and both for maximum likelihood classifier, because of its smaller pixel size, which is 20 meter, along with the narrower spectral channel bandwidths. Whereas Landsat 8 had 30 meter resolution of its pixel spatial resolution, and it had broader spectral channels, and also the different slide in the placement of spectral channels. So Landsat 2A is visibly more potent and powerful than Sentinel 2A is visibly more potent and powerful than Landsat 8 dataset for this objective of identification and monitoring of municipal solid waste dumps. Finally, I conclude my study with the fact that there are certain limitations in this study. The study is limited in the sense that it is only centered upon the optical and short-wave infrared domain of electromagnetic spectrum, and only pixel-based classifiers were used to conduct this study. The whole realm of object-based and subpixel classification and introducing other techniques and analysis in other parts of the electromagnetic spectrum will be left for the future researchers. And after mutual comparisons, the use of satellite data with high spectral and high spatial resolution is recommended for future studies. And also the integration of GIS in post-classification procedures is verified through this study. Thanks a lot for listening to me. If you have any questions, you can ask.
Thank you very much, Ms. Faiza, for this impressive presentation. Oh, I see Professor Cossu. So he's here. We will come to you later. Just a moment. So now, any question to Ms. Faiza about for her impressive presentation? So there is one, I think, in the chat from Dr. I.I. Singh. Remote sensing and GIS techniques are more suitable in areas where observation infrastructure is weak. So do you have any comment or any answer to this contribution, Ms. Faiza? So he says that remote sensing and GIS techniques are more suitable in areas where observation infrastructure is weak. So that's what you all structure your presentation on this information, but would you like to say some more thing?
Yes, I want to talk about it. I belong to a developing country, which is Pakistan is a developing country, and most of the world comprises of developing countries. In these countries, there are constraints but there are constraints of time, there are constraints of costs, money, and many other constraints. We lack equipment, novel scientific equipment for the detailed in situ and field measurements of these studies. So, as a preliminary approach to solve our problems, and as a preliminary approach to fill the gap between these two realms, we have to conduct certain researches which are cost effective. We want to have sustainable, cost-effective solutions for our countries. It appears very easy that you have an instrument and you go in the field and you start getting measurements from this. But where will the instrument come from if you don't have any?
Ms. Faiza, your I think connection is not very stable. So we hear you, but it's a little bit difficulty. So we got what you would like to say. Thank you for your answer.
Welcome.
Any other question? Okay, so you also mentioned that it's the resolution is very important when you would like to observe the lands with satellites.
Yes.
Thank you for this nice presentation.
Welcome.
Thank you. Okay, now I think I would like the help of the host, please. The host of the conference, the Professor Cossu is here.
Okay.
So would you like to make him as a co-host to make his presentation, Rafaela Cossu?
He is a co-host right now.
Yes. Okay. Then okay. Welcome, Professor Cossu.
Well, thank you.
Let me introduce you.
Yes.
We are now in session 2, which is entitled as Landfilling.
Yes.
Only one of the speakers is missing, But now we will go back to the first place that was for you. And today, from now on, we will hear the keynote speak of the session from Professor Cossu. Raffaele Cossu is a very well-known full professor of environmental engineering in the field of waste management. He is from University of Padova, Italy, and he's been working there since 1997. His research activities are mainly related to waste management and remediation of contaminated sites. And also, since 1987, he is the chair of the scientific committee of the International Symposia on Sanitary Landfills, held on a biennial basis in Sardinia. That's a very famous conference in the field of landfilling. And now we will listen his keynote speak, which is titled Role of Sustainable Landfilling in Modern Waste Management Strategies. Professor Cossu, the platform is yours. So the online platform is yours. Please go ahead.
Well, thank you very much, Mr. Chairman. First of all, I have to beg your pardon for being just 1 hour late, but I have that I was a little bit, I didn't care about the jet lag. So here in Italy, in this moment is 2 o'clock, and I was waiting still 1 hour to join your 3 o'clock p.m. meeting, without counting that we had 2 hours of difference in time. Luckily, I was just checking now, so okay. So, really sorry for that. How much time do I have?
Half an hour.
Okay, well, okay. Okay. Do you see my presentation now?
Yes, yes.
Okay. So now let us see if I can take out this. Okay. Well, now let us what we will be talking today. We know that circular economy now is the magic sentence for any modern strategy in waste management. So quite often people are considering that with the circular economy we can transform any waste in a new product, and that we don't need any more incineration, any more landfilling, because with the circular economy we can in a wonderful way recover any sort of waste. Now let us have a look at how the reality is. And we know very well, I think, all over this kind of triangular approach with a hierarchy in waste management: prevention, preparing for reuse, recycling, other kind of recovery, mainly energy recovery, and final disposal, mainly in landfilling. So this is the waste management hierarchy that we have in Europe. In Asia, quite often they are using a second kind of a triangle with the most preferred solution, with on top reduction, and in the end the less preferred solution, landfilling and incineration. This is a kind of I'm not really very in favor of this triangular approach, because it has a kind of a moralistic approach. Prevention is better than reuse, is better than recycling, is better than energy recovery, is better than landfilling. This moral approach is even more clear with the second triangle. I'm more in favor of a circular approach, because if we look at the triangles, then sometimes we look, particularly in Asia, you go for this is the theory and this is the practice. That the less practiced solution is just the prevention. We do very, very little prevention, I think, all over the world. And on the contrary, we still rely on landfilling in a large proportion. So the reality offers us a bottom-up triangle, contrary to the bottom-down triangle that we have with the European legislation and with the hierarchic approach. Now, what's happened? This one, okay. Okay, now we have a lot now of concept of terminology that are trying to explain the concepts of the resource recovery. And we are flooded by different definitions: waste minimization, urban mining, circular economy, material recovery, recycling, ecological footprint, zero waste, secure resources, eco-design, close the loop, landfill mining. Really, we have a lot of definition. And at the end, the main point is that we realize since long term that we have to recover as much as possible material from not only material and energy, because we are depleting our non-renewable resources. So there is a concern for the global consumption of these non-renewable resources. We have a progressive shortage of primary raw materials. We have a reduction of the available space for the disposal of the waste. We need a strong reduction, consequently, in terms of quantity and volume of the waste that we generate. We need a better control of the environmental contamination. And also the public attitude is changing. The people are strongly in favor of recycling resources from waste. So all these are, I think, well-known points to all of you, and I'm just mentioning in order to make a kind of frame to our speech. Now, how these different concepts that we were listing before are included one in the other. Landfill mining is just recovering resources from the old landfill, where we have several kinds of resources. Even if landfill mining, it is mainly practice for recovering space for new landfilling or for building or for some land planning reason. Landfill mining is done also for environmental purposes in specific situations, particularly with old industrial landfilling. Then we have the urban mining concepts. That is a concept that is made clear in this graph, where I try to summarize the general let us say, cycle of resources. We have two kinds of resources physically: stock materials, which means that the materials which are accumulated, and they can be either non-renewable, fossil, geological stock materials, like the primary raw materials that we have, the rocks, the water, the minerals, and anthropogenic stock material, or the material that we accumulate in buildings, with our mobile phones, with our cars. That is kind of material that we accumulate, but also in our houses. Think when we go to living in a house, what is the weight of the house? Is just some furniture, the bed, the fridge. But later on, we start buying DVD, we start buying books, we start buying several things, and printer, and so the weight of our house is increasing. So we have and we accumulate stock material. But then we have also flow materials. For instance, the natural flow materials are the materials which are produced with the primary production, with the new synthesis of organic fraction, which are renewable materials. with the chlorophyll synthesis, we are producing renewable materials. And this is kind of a flow materials, a material that is continually entering in our material resource system. Then, if we think anthropogenic flow material, these are typically the waste. So the waste that daily we are producing and we have to dispose of. So urban mining, theoretically, is the recycle and the reuse of the anthropogenic stock material. And this is just to okay, how to go back? Okay, I'm going back. So urban mining is something that is above landfill mining. Then we have the concept of material recycling. Material recycling is considering any kind of material, anthropogenic, either flow, either stock material that we are recycling. With the concept of the resource recovery, we include also the energy recovery. With the waste minimization, we are including any kind of system, either prevention, either avoidance, either reduction of the source, either product reuse that prevent or reduce the generation of the waste. And then we have the circular economy that is involving all of this system. With another graph, I don't know why, okay. With another graph, I represent the same concept where I give the significance to each difference, going from old landfill to urban mining. I'm considering the anthropogenic stocks from landfills, and this is the landfill mining. Then anthropogenic flow material, packaging waste, sewage gas, combustion ashes, and so on. So it's the same concept, but represented in a different way, and moving from waste minimization to circular economy. The main difference is that the circular economy means treating the waste, recovering waste and material in an integrated way with an economic and business management. And that's why it is stressed, the term economy. But in the end, the circular economy is just reflecting, let me see, okay, it's just reflecting this, is reflected in this graph. This is the typical European graph that are used for describing the circular economy. In the past, we had the linear economy. We extracted the resource, we use for the production, then we distribute the product, we consume the product, and then we waste, linear, directly to possibly a dump or a landfill. With the circular economy, I have production, distribution, consumption, reuse, recycling. So it looks like a perfect cycle. This was the first approach. The proposed action will contribute to, this is the sentences of the European plan, the proposal actions will contribute to closing the loop of products life cycle through the greater recycling and reuse, and bring benefits for both the environment and the economy. This was the book of dream, but the reality is different. The reality is this one, because we have to reintegrate continuously resources in the cycle, and we are producing waste. This is something that in the beginning was not considered. So as a result, if we consider the world situation in waste management, you have a situation like this one. I summarize the world situation in this two triangle graph. This is a system that I propose. The triangular graph are well known, but I was originally proposing this graph around, now it's about around 10 years ago that I proposed these graphs, and because they can allow to represent together the three main systems that we use for waste disposal: landfilling, thermal treatment, recovery, and recycle. Now, if we disregard these new products, that is, we will come back to that. So I have a recycling, I have a thermal disposal, and landfilling. Now, how to read this graph? I think that, I don't know, probably all of you are familiar with this graph, but if I have, for instance, landfilling, here I have 0% of landfilling, like I have in the utopia of the zero waste, and then I have 100% of landfilling as I have in several developing countries, with the waste management DC developing countries is the waste management. The only option is quite often is only landfilling. So if I have, and this is 100 of landfilling, the same here I have the thermal disposal from 0 to 100, and then recycling of material from 0 to 100. So if I consider landfilling, and here I have 100%, and I consider a line, this line, opposite to 100, means that here I have along this line 0 landfilling, here I have 10% of landfilling, 50% of landfilling, and etc. So in the zero waste, which is a realistic situation, I have 0% of landfilling. In developing country, 100%, and for instance, in Czech Republic, I have 70% of landfilling. In Austria, I have 80% of landfilling. Turkey, I think that is here. Greece is here, and this is Austria, 30% of landfilling. Japan, around a little bit more than 10%. And if you look, this is Switzerland, the Netherlands, this is Belgium, Germany. This is the situation in the 2006-2008. Now, around 10 years later, the situation, due to the implementation of the circular economy, looks like this one. So landfilling looks like going to 0. So here in this country, the landfilling looks almost disappear. But this is not true. This is a false message, because we should write here not landfilling, but landfilling of raw waste. So in this country, it is true that it is 2, 3, 4% the landfilling of the raw waste. But we will see that if we consider all the residues that we are producing here, and we can take as an example what's happening in a normal recovery of waste. If you have a waste source, you make the source segregation, the separate collection, and then you have some waste fraction, then you have the selection, and then you have impurities. Then from the selection, you start refining the different material, and then you have other rejects. Then when you go in the production, you have again other rejects. Just to make an example, with the plastic recovery, you have in a normal recycling process, manual sorting, ballistic sorting, magnetic separation from the light fraction, optical separation. Then you have the separation of PET, other plastic, aluminum, HDP, but you have also material residues, yeah, that is altogether for the plastic around 35–36% of plastics which are not recycled, even if they are coming from the separate collection. And this is just an example that you can see here. This is the garbage. This is what you separate. This is what you obtain after a first selection and shredding. Then when you are producing the granules, the PET flax, and then when you are producing plastics. All along this process, you are producing around 35% of the original residues. So, and this is just considering the plastics. So if you put together all this, is a lot of waste. The same with incineration. We know we all know that from the incineration we have residues that is in terms of volume is 10%, but in terms of weight is 30% of the original waste. So if I implement this in a graph, then we will see that we are sending to landfilling not zero, but around 20–25% of the waste that we are producing. So we are underestimating the role of landfilling, even if in the most advanced reality where we are recovering at a high percentage our waste. So the ambitious goal of the European Union of closing the loops in a circular economy cannot be reached if we don't address properly the management of the residues. This is really amazing that in Europe we are taking care of separate collection, funding separate collection, and we are having this is true all over the world, a regulation for landfill that is not sustainable. And I will come back to this concept. So we have to consider that all the resources that we are recycling, plastic, paper, metals, etc., that we are recycling for producing new products, and these are the loop of the circular economy, we have residues, and these residues should be treated in order to avoid contamination, because then these material have to go back to the earth. And this is a simple concept that I would like to let me see if I have after. I hope that later on we can go. Okay. I want to go back here. Yes, we have to be well aware that is the cycle that we are using. We have a soil. From the soil, we take material resources, we extract, we produce, as we show later, we use, we collect the waste, we produce waste, we collect the waste, and then, sorry, this is in Italian. Hello? This is in Italian, and then we have to reuse and to introduce in the back again in the cycle this waste. And this is the cycle of the circular economy. But the material that are residuing from the circular economy, from recycling, the recycling loops, then we have to treat them. To treat them because otherwise the pollutants that we have, the contaminants that we have in this waste can create and can enlarge the most serious problem, environmental problem that, in my opinion, we have nowadays, that is the continuous increasing of contaminants concentration in in our planet. If you go in the Pole North, in the South Pole, in the oceans, is continually increasing the concentration of heavy metals and the persistent organic pollutants. So in order to avoid the diffuse contamination, and this is all the contaminants that we emit in any phase of treatment of the resources. When I extract some material, I'm producing waste. When I produce waste which are water, which are solid waste, which are atmospheric contaminants, and these are emitted even respecting the standard limits. But the standard limits are based on concentration, time, the flow of effluents that we are emitting in the environment. We are continuously having a high load of contaminants in our world. So what we have to do is to take the residues and bring back to the soil. This is a concept that should be really very, very well clear and accepted, because to deny this is like to deny the Lavoisier principle. If we take cadmium here, we can make several loops, several circular economy loops. But if we don't give back to the soil the cadmium that we removed, then this cadmium will be around us. So it is an ecological footprint to close the loop and to have a material cycle. And the landfilling can play this role, like we have in the normal cycle. This is the cycle of the carbon. I mean, I will not now describe into details this, because I have calculated that I have still 8 minutes, so I don't want to. I would like
we have about 5 minutes. Maybe it's better to give some time for the questions, Professor.
Okay, fine. Okay, I give
the last 5 minutes, please.
Okay, I just block 5 minutes so that I will have some ring in me. Okay, then in the carbon cycle, we know the carbon cycle from the atmosphere, the synthesis, the photosynthesis. But then in the carbon cycle, we have sediments. We have sediments for the soft part, for the hard part, and we have oil, limestone, coal, and natural gas. So, and we have through the decomposition, the diagenesis, we have the fossil deposits. So we have in this natural cycle, and with the circular economy, it is the same. We use, we recover, we waste, mechanical treatment, biological treatment, thermal treatment, we have the production, but then we need a deposit, a back to earth site. So this is the role of landfilling. So we cannot think that we can avoid landfilling. The only thing that we have to do is that we have to consider that landfilling is not something that have to be rejected. It's not the nasty boy of the waste management solution, but is the environmental tool for making possible the circular economy, is the environmental tool for closing the loop of the material. Respecting Lavoisier, nothing is created, everything is rotating, and nothing can be destroyed. Well, now, coming to this means that the landfilling should be conceived in a different way from the traditional landfills, that we know that the traditional landfill is creating a lot of problem in terms of contaminants. But what we have to do, we have to treat the waste in order to reduce or block the mobility of contaminants. Something that so we can minimize the waste, we can make pre-treatment, we can make, of course, collection of gas, we can make in situ treatment, we can use barrier top cover, we can use bottom barrier, we can collect leachate. So we can put together all the possible barrier, either the active barrier, like treating the waste, minimization, either the passive barrier. With this concept that is represented in this slide. So the landfill should be acting as a sink in the circular economy, like I told you, in the carbon cycle. And what we have to do when we have the residues, we have to pre-treat them, reduce this is an example of the organics, reduce the leachable organics, reuse the gasifiable organics, reuse the solid organics in order to have fixed matter. And this fixed matter, this immobilized contaminant, in this case immobilized carbon, have to be continually reduced until I reach a final storage quality, or even better, a rock quality, where all the contaminants are in a form that are anymore which cannot anymore be mobilized. So in a kind of sort of geological deposit. So if I consider the final emission from landfilling, this is like an open dump. So this is the time. During the operation, the open dump is producing a lot of contaminants, but also in a confined landfill, that is the traditional landfill with the bottom liner. When the bottom liner are in a good health, in a good efficiency, I don't have emission. But when after several years, after 30 years, after, if I have here the operation, this is the closing of the landfill, then this is the aftercare time. Normally in Europe, we consider in this period of the 30 years of aftercare, then in 30 years, the liners, either the clay, either the geomembrane will fail, will start leaking. In this case, if we didn't do any kind of pretreatment, then the leachate emission will oversee the sustainable amount of leachate, which can be in equilibrium with the environment. What we called the final storage quality, which is acceptable for the environment. But in a sustainable landfilling, this is a really important concept, that the landfill should be sustainable. The emission, this is concentration of leachate, and this is flow of leachate. Well, so the amount of leachate will be, after 30 years, if I pre-treat the waste, below the environmental acceptable limits. In conclusion, after 30 years, I can release the landfill without the risk of environmental problems. And we have to strive for that, because we have several problems in our life, not only landfilling. For instance, housing. Sometimes we have a house which collapses. In the earthquake of Aosta, most of the people died because the housing was not of good quality. Then in the bridge, you know that in Genoa, a bridge collapsed with 40 people which were killed. Then also the landfill can be a source of contaminants, of many problems, and even injuries and even deaths. But then what is our conclusion? That we don't make any more housing, that we don't make any more bridges, that we not make any more landfills. No, we have to make nice houses, sustainable houses, where the people can live without risk. We can make bridges which are not falling apart, which are not collapsing, and we can make sustainable landfill which close the loop of the material and we can use. In conclusion, if the politicians like to talk a lot of circular economy, we all have to be aware that without landfilling, no circular economy would be possible, and we have to fight as a scientist for regulation where should be included in all the regulation that we have on landfilling, that landfilling should be sustainable. And then include in the regulation all the tools for making it sustainable. On the contrary, sometimes we think that the landfill is a nasty guy, but we don't do nothing for improving this, and from educating this nasty guy and bring him to a safe system. So I hope that I respect the time, and I'm open to any question from your side. Thank you.
Thank you, Professor Cossu. I would like to applaud. So it's very, very nice, and starting from the fundamental to the practice. So we are really very happy to see you here in the session, and we are glad to follow this nice presentation. Now the floor is open for questions, if any. There are something in the chat box. So from Rafizul Islam. So thanks Professor Cossu for such informative and nice presentation. Basically, landfill cannot be stopped fully. We should minimize waste generation from source household, especially in Bangladesh. So thank you for this comment, especially in Asia and also in the Middle East. In this part of the world, we have similar problems in the Eastern Europe, in the Balkans. Yes, any question? Any comment?
This is Rafizul from Bangladesh. Not a question. Just I'd like to thank Professor Rafael Cossu, because he is very famous unknown person to me. He visited several times in my Bangladesh, especially my university. And last time I also meet with him in Italy in 2019. So thanks for your nice presentation. I'm really happy.
Hello.
Yeah, how are you?
Hello.
Hi, thank you.
I'm Dr. Kumar speaking from Lucknow, India. Hello.
Hello?
Hello.
Hello?
Hello.
Hello?
Yes, please.
I am audible? You are hearing my voice?
Yes.
Well,
Hello.
more or
Do you
less.
have any question?
Yes, I am Dr. Kumar. I want to present.
Do you have any question to Professor?
Hello. Yes.
Please.
Okay. Hello. Hello.
I think it's a misunderstanding. So it's any other question to Professor Cossu?
Yeah, I am Sandhya Babe from Thailand.
Please.
I also met you before. I have a question. So from your presentation is very nice. I just want to know that if my understanding is correct, that it's landfilling should be mostly for the residues. That's
Yes.
what you mean?
Yes.
Is it correct?
Yes.
All the residues, we have no option to do it either from the incineration or from another process, then would be the good choice to do it onto the landfill. That may help to close the loop and have material recycling into the nature.
Yeah.
Is it correct?
Yes. Yes. Exactly this. So I mean, the landfill, it is like a circular economy. Is a mechanism where you, as we saw, we have. I don't know how it is in English, engranaging. You know that you have like in a clock that you have several wires that move. You know, same, I don't know really the English term, but each part is important. If in a clock to remove one small part, then the system is not working. So it is exactly this, that whenever we have, of course, to recover resources, of course, in a serious way. Sometimes we recover resources, spending more resources for recovering than from what we get. But exactly this material, we should avoid that go around contaminating the environment, and we have to bring back to the earth. This is the main strong concept that we are implemented already in a, I mean, just recently we published the detritus journal. I don't know if you are aware of this journal that is open source, but is fully open. Is free for the authors and free for the reader. I hate that journal where you have to pay to publish something. Then at the end you don't know if you have been published because you paid or because your paper is good. So the detritus is an open journal that is more or less financed by different universities, and so no cost. Well, in this journal we published a recent paper on guidelines for making a sustainable landfilling, and it is clear that these residues have to be treated before being landfilled. Just to
Professor, thank you for your explanation. I think the missing presenter is finally reached, so we have one more presenter, if I understood correct. Virendra Kumar, are you here? Can you hear us?
Yes, sir, I am here.
If you are here, I will give you
yes,
time.
I am here, sir. Yes.
Otherwise, I will let the people ask some more questions, but I think, as I understand, you are finally here. Professor Cossu, thank you very much for your keynote speech. And we are really delightful for that. And it's very nice to welcome you here.
Thank you, and sorry again for the delay. Really,
no problem. Okay. Thank you.
Thank you.
Yeah, it's now the last speaker, but we don't have so much time. So it's the program is all messed up. So Dr. Kumar, so please.
Yes, sir.
Only 10 minutes. Could you please?
Okay, sir. Okay, I will finish. I will sum up within 10 minutes. Okay.
Quite directly start maybe from your materials and methods or something like that. Okay, please, the platform is yours.
Okay, sir. Okay. Okay. Share करूँ.
You can share your presentation, directly your presentation. And also please unmute yourself. Dr. Kumar, can you hear me? Dr. Kumar, can you hear me? I think problem in the connection. Maybe he tried several times. I don't know, because Dr. Kumar, are you here?
No.
Yes, sir. I am here, sir.
Okay.
Hello. I am here, sir.
I can hear you, but it's we don't have so much time. Please start your presentation.
Okay, sir. Okay, sir. Okay.
We are waiting you. And the time is flying. Because we will have one more session. It will start in 15 minutes. So we are now getting experiences with the online conferences. So it's when you are all in the floor or in the hall, all in the hall, it's easier to manage. But now it's we couldn't follow the list, we couldn't follow the program. But in any way, so I think Dr. Kumar has some connection problems. I see that in the chat. Can I ask a question in the meantime? Maybe a question to Professor Cossu. I can imagine that your question is to him. We are waiting, but maybe please ask your question. If Dr. Kumar can connect, we can stop and get your answer later on. Okay, please go ahead. Tasmin.
Tasneem. Hi,
Okay.
I'm a student from Yildiz Technical University.
Please ask your question.
Professor Cossu, the main problem for landfills is usually the area that countries have. It's why they wanted to do zero landfills. So how does sustainable landfills solve this problem?
Well, exactly this. That's the point of the space is related to the fact that we are landfilling the raw untreated waste. But if we activate all the possible recycling, the reuse, the residues will strongly reduce, and we can use them as a part, and this is another important aspect in the landfilling, sustainable landfilling concept, as a kind of aspects in shaping and changing and making landing planning use of the waste. I don't know where you come from, but I didn't catch your country name. Tasneem.
Where are you from? Tasneem?
I'm a student at Yildiz Technical University. I'm originally from Syria. But my question is, like, for countries like in Japan, they don't have the area, the space to do landfilling.
Yeah, so, no, okay. So it's not talking about your country. In Japan, they are already using landfilling. They use landfilling almost for 20%. That's why landfilling and Japan, which is a country which I know very well. I go quite often there. They reduce very much the use of landfill. As a matter of fact, they incinerate almost more than 80% of their waste, so reducing the volume of waste to 10%. So in Japan, they have already that, and they are using for instance, they use for recovering some soil to the sea. They having this stabilized waste. They can use it for reshaping, for making some parks, and so they are dealing with that. And also you can use in that situation another kind of landfilling for closing the loop. That is, when I say back to earth sites, I am including also recovering the ash, making a building material that you are using in a house, in a bridge. And this is a landfilling. We have to be aware of that, because we are putting that in the land. And that's another reason for controlling the contaminants. Because if you're recycling the ashes in a bridge, and then this bridge is leaking, then you have a problem. So the concept of back to earth, it is not only landfilling, but can be also reuse of building material or composting, reusing the soil. In any case, is the same concept that in this cycle material, you need a sediment, you need a back to earth site.
Okay, thank you very much for this contribution also. So it's building materials or putting the ash into the buildings. That's another way to landfill the residue on the earth. So Dr. Kumar, if you can hear me, we will move you to the next session. So it's I got a message from the host, from the secretary.
Yes, sir.
So it's you will make your presentation.
Hello.
In the next session.
Yes, sir.
You have some, okay. If your connection is stable now, it's the next session will start in 10 minutes. So your presentation is moved to that session, okay? So now I would like to close.
Okay, sir.
I would like to close this session. Thank you very much for all the presenters. So it's from my point of view. So it's personally, I got very good information from different researchers from all over the world. And I would like to thank you one more time. Thank you. And thank you for the all participants, and hope to see you in a healthy days and years in the next year, maybe sooner. And okay, goodbye.
Teşekkür.
Okay, thank you.
Okay, ciao.
Ciao.
Mr. Raphael, thank you. Okay.
Ciao.
Allah'a ısmarladık. Okay, thank
Ciao.
you.
Thank you.
You're in Venice. Ciao.
Goodbye.